In this video, we're going to be talking about acids and bases and about the Arrhenius theory, which helps in explaining their properties. So previously, an acid was considered to be something that tastes sour, or if you said on the basis of taste, an acid was something that had a sour taste, and a base had a bitter taste. But this is not a very good way of classifying things. This can lead to mistakes and it is very inefficient. Let's say someone has said that they have a substance which they want you to taste and identify whether it's an acid or a base. And if that substance turned out to be HCl or hydrochloric acid, I don't think it would be a very good idea to do that. So the first theory we will be talking about is the Arrhenius theory. So according to the Arrhenius theory, an acid is a substance that has hydrogen atom in it and when dissolved in water gives rise to H plus ions. So let's take an example. Say we have hydrogen fluoride and we add water to it. Oh, never add water to an acid. Add the acid to the water. So we dissolve it in water and that gives us H plus ion plus F minus. Let's say we take H2SO4, a sulfuric acid, and dissolve that in water. So that gives us H plus ion plus the SO4 minus. But notice the 2 here, that's going to give us 2 hydrogen ions. So this, according to the acid, is something that has a hydrogen atom and donates a positive hydrogen ion or a cation when dissolved in water. So now let's go to the definition of a base. According to the Arrhenius theory, a base is a substance that has OH group or hydroxyl group and when dissolved in water or in aqueous solution gives rise to OH minus ion. Say we have NaOH, sodium hydroxide, dissolve it in water, we get Na plus and OH minus. Let's take another example, calcium hydroxide. We add it to water and we get Ca plus and OH minus, but there are two OH here, so 2 OH minus. So this is a base, has an hydroxyl group in it, and when dissolved in water gives rise to OH minus ion. So let's see what neutralization is according to the Arrhenius theory. The Arrhenius theory says neutralization is the formation of undissociated water. Undissociated, that means just not broken down. So this is dissociated water and it has broken down, so it's dissociated, and this is undissociated water. So what happens in a neutralization is the H plus ion from an acid reacts with the OH minus ion from a base to form water or undissociated water. Let's take an example. Say we take hydrochloric acid plus potassium hydroxide. So it reacts to form potassium chloride plus water. We could see it like here. The hydrogen from the hydrochloric acid reacts with this OH group, hydroxyl group from the potassium hydroxide to form this water. The H plus ion from an acid reacts with the OH minus ion from the base to form undissociated water. So every theory has some limitations. So does the Arrhenius theory. Now we're going to be discussing about those. The limitations are it is only applicable in an aqueous solution or when dissolved in water. We cannot identify the properties of acids and bases if they are in the gaseous state or dissolved in any other liquid, and it cannot explain the acidic nature of non-metallic oxides that do not have hydrogen in them. Let's say carbon dioxide or sulfur trioxide. though they do not have an hydrogen, and according to the Arrhenius definition, we cannot explain the properties of these acids. And also it cannot explain the properties of the basic properties of those metal oxides which do not have OH groups. Let's say magnesium oxide or NH3. This NH3, let me write it down here, NH3 or ammonia. This is a base, but it does not donate a OH minus. What it does is, we'll see here, when it reacts with water, it forms NH4 plus, or it takes a hydrogen ion from water, and that leaves the OH minus. And this is the Bronsted-Lowry definition, which we'll be seeing in the next video, an acid as a proton acceptor. And also there are other limitations. Don't worry about this, we'll be talking about this in the next video. And then there is the H plus ion. This was afterwards was proved that it is not stable. It cannot stay like this. It reacts with water to form hydronium ion or H3O plus. And the other thing is that when water is not formed in the neutralization reaction, this cannot prove it. Let's say we have some lime or calcium oxide, and we add some carbon dioxide to it. This forms calcium carbonate, that milky white solution. So this is a metallic oxide or a base, and this is a non-metal oxide, an acid, and this is a neutralization reaction. But since water is not formed here, the Arrhenius theory cannot explain it. So this is all about the Arrhenius theory. We're going to be talking about the Bronsted-Lowry theory in the next video.